Hello everyone, welcome back to the channel. My name is Matthew Sanabria. In this video, we're going to cover every single Terraform command that is currently in the Terraform binary at the time of this recording. Now, I'll introduce each command, I'll show a practical example of actually using that command, and I'll probably discuss why or when that command might be used in a given scenario. Hope you enjoy the video. This video is divided into two parts. We'll cover the main commands first, and then we'll cover the other commands afterwards. Now, what do I mean by main commands? Well, if you run Terraform, it'll list out here some of the main commands that it knows about, and those are what I consider the main commands. And then for all other commands, they're listed down here. So we're going to go ahead and cover all of these in the order that you see it here appeared on your screen. The Terraform init command allows you to initialize Terraform so that you could begin working with it and running other commands. The initialize command has a bunch of options that you can see if you run terraform init --help. If you read the top, it'll say this initializes the new or existing Terraform working directory by creating initial files, loading remote state, downloading modules, etc. This is the first command that should be run for any new or existing Terraform configuration, and it sets up any local data that you need. So basically, you need to run this command first before you can actually run other Terraform commands like plan or apply. The init command has a bunch of options here that I'll let you read through and make sure, and you can find out if it works for your use case. I'm not really going to cover the options, I just want to cover what init does. So in order to use init, you need an actual Terraform configuration file. Well, we have one here called main.tf. Now keep in mind, Terraform will read any star.tf files in your current directory. So I can have a file called 1.tf, 2.tf, 3.tf, whatever. The convention is that your file should be called main.tf, but it will read all TF files in your current directory. And people usually split them out into different logical separators like app.tf, db.tf, whatever it may be. But main.tf is convention when you only have one file. Let's take a look at our configuration here. We have a Terraform block at the top that details our required providers, and you can see that we're using the DigitalOcean provider version 2.6.0. Then beneath that, we have the provider block for DigitalOcean. This is going to provide the provider's configuration, how we authenticate to DigitalOcean. If you look at the comment right above it, the provider configuration is actually coming from environment variables because that's more secure. Notice how I'm not actually hard coding any tokens or anything in here. Those are going to be read from my environment variables. You might pass it yourself, but this is a more secure way, and this is how I'm doing it for this configuration. Then I have a variable declared called namespace. This variable is going to just hold an arbitrary string that's going to be used to uniquely identify resources, and it's going to prevent naming collisions. Certain providers don't allow you to create multiple resources that have the same name. For example, in DigitalOcean's case, I can't create two SSH keys that have the same SSH key inside of it. So a variable like namespace will allow me to get around something like that. And you'll see that later on how it becomes important, but it's really just here to prevent naming collisions. And I know I'm not using it for the SSH key in this particular example. I'm only using it for the droplets if you look down below. But it's a good habit to get into because it allows me to run this same configuration multiple times with a different value for namespace, and I can get unique resources. So I don't have to change my configuration when I want to, update different resource names. Next, I have a data source. This is going to reach out to DigitalOcean, fetch the SSH key named admin SSH key, and allow me to actually access its attributes from within Terraform. Now, this admin SSH key is already pre-created manually in DigitalOcean. I'm just going out and reading it with Terraform so that I have access to its attributes in the rest of the configuration. Then I have 3 DigitalOcean droplet resources here. One called app, one called DB, and one called Bastion. These are just meant to simulate some virtual machines that you might find in your cloud provider. Here you can see we're using the var namespace variable, and that's going to prefix all of our resource names with some arbitrary string, so allow us to identify them and namespace them. And then for SSH keys, you can see we're reaching out to the data source and we're grabbing the SSH key ID so we can attach it to this droplet. And we're doing that for each droplet. And this is just simulating 3 different types of VMs you might see in your infrastructure. Then at the end, we have this output called info, and all it's doing is it's returning us a map. And the map is going to be, the key is going to be the type of VM that we're looking at, like appdb or bastion, and the value is going to be their respective IPv4 addresses. So a good spread of Terraform keywords that we're using here, right? Provider, variable, data, resource, and output. Great. So now we want to init this configuration. Well, if you just run Terraform init, it's going to initialize the configuration in your current working directory. So as I said before, I just have one file here, one main.tf. I actually don't have anything else, if you see. And if I just run Terraform init, it's going to initialize my backend, which in this case it doesn't really matter too much because this is a local backend, not a remote backend. We'll cover backends probably in a separate video. But the most important thing is it's initializing my providers. It's actually reaching out, finding the DigitalOcean provider, installing it, and then making sure that it's, signed by a partner or something. If I had modules in this configuration, which I don't, it'll actually download the modules at this point too. So when you run Terraform init, at the very end, you should see some text that says Terraform has been successfully initialized. At this point, you can start running other commands like Terraform plan or Terraform apply. But what does it mean to initialize Terraform? Well, if you just run ls again, you'll notice I have a main.tf file. So you might be saying to yourself, what changed? Well, if you run ls-la, you'll see these two files that were created, a .terraform directory and a .terraform.lock.htl. You could ignore the lock.htl, that's just a 0.14 and newer feature, but the .terraform directory actually has a lot of stuff in it. So if I run tree against it, you can see that the actual providers were downloaded and installed into this .terraform directory. So Terraform init went and reached out, downloaded the DigitalOcean provider, and installed it in this local .terraform directory. This now allows Terraform to talk to the DigitalOcean provider binary, which is right here, and actually make changes to the DigitalOcean infrastructure. One last thing that I want to cover about init before we wrap up on this command is this is kind of a lesser known feature, I guess you can call it, of Terraform. Most of the time, you're just going to run Terraform init, and you might pass in some options, you might not, depending on what you're doing. And that's fine. We already covered that Terraform init operates on the current working directory, but it also takes an optional directory argument here. And if you wanted to, you can just run Terraform init and then give it the path of a directory that's holding your Terraform configuration, and Terraform will init inside that directory for you. So you can be somewhere else on the file system and run Terraform init, give it the path of the directory, and it'll go init in that directory. It's kind of a lesser known feature, I would say, but something I wanted to note because it comes up from time to time and people don't really know that you can pass a directory here. And that's Terraform init. Terraform validate allows us to validate whether or not a configuration is correct syntactically. So if I run Terraform validate --help and read through it, all it says here is it validates whether the configuration files in a directory are valid, right? It checks whether the configuration is syntactically valid and internally consistent, regardless of any provided variables or existing state. So basically what this says is the Terraform configuration syntax correct? Did you make some sort of typo, some sort of, syntax error? Validates will confirm that for you. And usually you want to run this on a already initialized directory. So I already have an initialized directory here because I already ran Terraform init previously. But if I just run Terraform validate, it's going to report back success. The configuration is valid. I don't have any syntax errors here. So let's make a syntax error. I'm going to actually go in here, and instead of calling var.namespace, I'm going to call var.namespock. And now if I run Terraform validate, you'll notice it says, hey, you have a reference to an undeclared input variable. You have var.namespock, and an input variable with the var.namespock has not been declared. And it's going to say, did you mean namespace? So it's going to try to make recommendations here, and it's going to help you catch your syntax error. Terraform validate is really useful to be run in a CI environment, in an automated environment, to check whether a given change to the code is still valid. So now if I go back and fix this and I put var.namespace instead, rerun validate, it says success, the configuration is valid. So again, this is good for checking your syntax and seeing if it's okay. Now it's not the source of truth by any means. You should still do other things like run a plan and check the plan file. But from a syntax standpoint, validate's always good to run on your code on each change. And that's Terraform validate. Terraform plan allows us to actually run a plan and see what changes Terraform wants to make. So if we run Terraform plan -- help, you'll see here there's a bunch of options that, again, you can read through at your leisure and see if they make sense for your given workflow. But all Terraform plan does is it generates a speculative execution plan showing what actions Terraform would take to apply the current configuration. It'll not actually perform any actions. It's just going to show you what Terraform would do, or what Terraform would want to do if you ran Terraform apply. Terraform plan is actually a really, really fun command, especially when you get into cool options like detailed exit code, which I highly recommend other people to look at, especially in a CI environment. And I think we'll cover just the output option here. But Terraform plan allows you to see in more of a human readable way what Terraform wants to do. Let's run it. So mind you, in order to run Terraform plan, you need to have already run Terraform init on your configuration and initialized Terraform. Since I already did that, I can just run Terraform plan and see what Terraform wants to do. Well, the first thing that Terraform wants to do is it's going to prompt me for a value for my namespace variable. And that's because I never gave that variable a default. So when you don't have a default on a variable, it makes it a required variable. So Terraform's saying, hey, what do you want this value to be? And for me, I'm just going to name this one default. That's going to be the value that I'm passing because it's going to be my quote unquote default namespace. And then now you'll see that the rest of the plan went through and it shows that Terraform wants to create all of these resources. It wants to create my app VM, my Bastion VM, and my DB VM. At the very end, it gives you a little summary. I want to create 3 things: change nothing, destroy nothing. And a notice is also going to say, hey, you have outputs that are going to come out of this. At the very end, you can read this note. It says, you didn't specify an out parameter to save this plan, so Terraform can't guarantee that exactly these actions will be performed if Terraform apply is subsequently run. What that means is certain things can change when you run Terraform apply, because every time you run Terraform plan, Terraform will reach out and refresh any data sources that it's aware of. So in this case, I have one data source in there. I have the SSH key data source. Every time you run plan, it's going to refresh what it knows about the data source, right? So when you go to run an apply, well, an apply actually runs a plan first. So if that data source happens to change between the time you ran plan and the time you ran apply, that's what this is saying here. If there was a change between that point in time, Terraform can't guarantee it because you ran plan and apply at different times. However, this is why I like to cover the out parameter. If you ran Terraform plan and you ran out equals plan.tfplan, and I gave my default value, it's going to show you the plan file again. It's going to say 3 to add, blah, blah, blah. But it's also going to say this plan was saved to a file called plan.tfplan. To exactly perform what this plan is showing you, please run Terraform apply and then point it to the plan.tfplan file. This is super useful in a CI or automated environment because you can run your plan, send it to an output file, kind of tar up or archive your entire working directory with the plan file and the configuration, ship that as an artifact, and then later on when someone approves the plan, you can have someone just run Terraform apply and point it to the plan file. This is kind of the way, this is called the 2-step of plan. I would say the 2-step apply. You run plan in and out, you run plan and output it to a file, and then you run apply on that output file. This is how actually Terraform should be run in a CI environment. And this is actually how Terraform is run in Terraform Cloud or Terraform Enterprise. So if you're a user of one of those, this is actually how Terraform is being run here. So again, it depends on your use case. If you're just running Terraform from your workstation and you're not doing any automated, CI, then you might just run Terraform plan, then Terraform apply, right, back to back. But if you are in a CI environment, you might want to consider using the out parameter here and saving the plan file to an output. And that's Terraform plan. Terraform Apply will actually reach out to the provider and perform actions that were detailed in the plan. Now, if we look at Terraform Apply and it --help, you'll see a bunch of options here that I'll let you read through in your own time and decide if they work for you. But Terraform Apply will create or update infrastructure according to the Terraform configuration files in the current directory. By default, Terraform will generate a new plan and present it to you for your approval before taking any action. You can optionally provide a plan file that was created by a previous Terraform plan call, in which case Terraform will take the actions described in that plan without any confirmation. What does that really mean? Well, let's run Terraform Apply and find out. The very first thing Terraform's going to want to do is it's going to want to prompt for any required variables that it doesn't know its value. So in this case, it's prompting me for the namespace variable and it wants a value. I'll give it the value default since that's what we were using before and hit enter. And you'll notice Terraform presents you with an execution plan and it says, hey, I want to create the app droplet, the Bastion droplet, the DB droplet, and at the very end it says there's 3 to add, 0 to change, 0 to destroy, and here are some outputs that you might want to be made aware of once the apply is done. Any value here that says known after apply, well, that's exactly what it means. It means the value for this attribute, for this resource, will not be known until the apply is complete. Okay? And notice at the very bottom, it's stopping and it's prompting you, do you want to perform these actions? If you type yes and hit enter, well, it'll take you through and it'll perform the apply. But we have that plan file from before and we might want to use that. So I'm going to hit Control C to cancel out of this. And you'll notice I still have my plan.tf plan from an earlier plan that I've performed. Well, if I just run Terraform apply, let me hit clear. If I just run Terraform apply and pass it the plan.tf plan, hit enter, what happened here? Well, you'll notice it's not prompting me for my namespace variable anymore, and it's not even prompting me whether I want to perform these actions. It's just going off and performing the apply immediately. Again, these are 2 different ways to run an apply operation. The first way you might run on your workstation, and the second way that we're running right now, you might run it in a CI environment where you have some automation. And this second method is really just called the 2-step apply, where you run the plan with an output file, and then you run apply, passing it the plan file. That's that 2-step apply. And you'll really see that in more of a CI and automation environment. And in fact, that 2-step apply process, that's how Terraform Cloud and Terraform Enterprise applies changes in its process. Once the apply is complete, you'll see a little paragraph that says, the state of your infrastructure has been saved to the path below. This state is required to modify and destroy your infrastructure, so keep it safe. If you want to inspect the state, you could run Terraform show. We'll cover Terraform show a little later on, so we'll skip that for now. And you'll see the state path is terraform.tf state. So if I run ls, I can see a new file called terraform.tf state. And if I cat that file out, it's a large JSON file that just says all of the resources that are being managed with Terraform. There's a data resource called SSH key, whose name is admin and yada, yada, yada. There's a managed resource called DigitalOcean Droplet, whose name is app, whose provider is this, whose instances are this, whose attributes are that, etc., etc., etc. This state file holds a JSON representation of all of the infrastructure or all of the resources that Terraform is managing for you at this moment in time. Why is this useful? Well, this is useful because when Terraform runs certain commands, it needs to consult its state file to see, hey, what resources should I even be working with right now? What resources should I even be touching? And this is how it knows. And you'll see that more in later commands. But that was Terraform apply. Terraform destroy allows you to destroy infrastructure that's being managed via Terraform. And in fact, it's actually kind of a funny command to see the help from because it's only a 1-liner. All these options, again, you can review in your leisure and see if they work for you. And if you look at the 1-liner here, it says destroy Terraform managed infrastructure. Well, what does Terraform managed even mean? If you recall from before, if we cat out this Terraform state file that we're using, in here is a JSON representation of all of the resources that Terraform is currently managing. So when it says destroy Terraform managed infrastructure, what it means is destroy all infrastructure that's listed in its state file. It's not going to destroy anything else. So you can rest assured that other resources that are created in your cloud provider or your infrastructure provider, they won't be touched unless they're in this state file. So let's run Terraform destroy. It's going to prompt me for my namespace variable because it's a required variable. And I can go ahead and type in default here. And you'll see that a plan has been generated and saying, hey, I'm going to destroy all of these things. Your app droplet, your bastion droplet, and your DB droplet. And you'll notice it'll sit here and prompt you, do you really want to destroy all these resources? If you were to type yes and hit enter, Terraform will actually go to your provider and destroy all of those resources, no problem. But let's hit Control C for a second because I want to show you something. Notice how when I ran Terraform destroy, it prompted me for my namespace variable. Let's say I gave it something completely different and I just typed the value typo. What happens? Well, the destroy plan still goes through. Now, why is that? If there is no resource called typo-db-droplet or typo-app-droplet, they're called default, right? Because that's what I gave the namespace when I applied it. Well, that's fine. But imagine what I said before. Terraform only destroys Terraform managed resources. So regardless of the value that you give that namespace variable, in this case, if you look at the state file again, in here, there's a managed resource called DigitalOcean Droplet whose name is DB, comes from this provider, etc., etc. And here are its attributes. And you'll notice the name attribute here is default DB droplet. But you might be saying to yourself, well, I just passed in the name typo, so why is it not trying to destroy a resource called typo? Well, that's because it's not listed in its state file. So what happens here is when you run Terraform destroy, it reads this entire state file, it finds all of these resources that are managed, and it says, hey, give me the ID from it. So what Terraform destroy is going to do, it's going to read the state file, and it's going to find the ID of every resource it wants to destroy. In this case, it's going to want to destroy resource ID 238883080. And that's how the Terraform provider actually knows how to destroy infrastructure on a given provider, because it'll reach out to DigitalOcean and says, hey, I want to destroy a droplet ID 238883080. That's how it uniquely identifies the resource to destroy, which is why the state file is actually super important. And that's why you should keep it safe. So let's go through with the destroy. We'll just change it back to the default. Really, this value doesn't matter. It might matter depending on how you're using variables in certain configurations, but for this configuration, the value doesn't matter because we're running that destroy. And it's going to say, hey, do you want to destroy? We'll say, yes, we do. And you'll notice it's destroying and it's giving the IDs 238883080, 3081, 3079. It's reaching out to DigitalOcean and saying, hey, can you destroy the droplet with ID this? Can you destroy the droplet with ID this, ID this? That's how it's limiting the destroy to only what's managed in the state file. Once the destroy is complete, you'll see something like this saying the destroy was complete and how many resources were destroyed. Now, you'll notice we still have the terraform.tf state file and probably a backup because this is another operation that we've done. Every time you do subsequent operations, Terraform wants to make a state backup file, which is fine. But the terraform.tf state is the primary state file. So if you look at that now, notice there's a lot less content in here. There's no resources anymore. Because since Terraform now destroyed them, it removed them from the state file, so now they're no longer Terraform managed. Well, they can't be Terraform managed because they don't even exist anymore. Terraform destroyed them. Now you can begin the whole cycle again. If you wanted to recreate the resources, you'd reapply it. If you want to destroy them, you can destroy them, and etc. And that was Terraform destroy. Terraform console allows you to open up an interactive console where you can type and test Terraform interpolations. Now, if I run Terraform console -- help, you'll see here it says it starts an interactive console where you can type interpolations and expect their values. This command loads the current state and it lets you explore and test interpolations before using them in future configurations. This command will never modify your state file. This line here, this command loads the current state, that's super important because it allows you to test interpolations as they apply to your state file. Now, I already have a applied file here. So if I cat out my Terraform TF state, you'll see it has my resources inside. So there's data in this state file, right? So if I were to run Terraform console, it's going to drop me into this console here where I can begin to type interpolations. Well, what is an interpolation? Well, an interpolation can be a Terraform function call, a resource identifier to grab an attribute from a resource, and those are things that we've, kind of already seen. So if I just start typing DigitalOcean droplet.app, because that is one of the configurations I have in my files, right? I have a resource named app that is a DigitalOcean droplet type. So if I hit enter there, it gives me everything it knows about that resource. And I can do cool things with this, right? I can start getting the ID here. I can get other things like IPv4_address, and I can build these interpolations. Well, Terraform also has certain functions that you can use. So if you go to the terraform.io page and you go to the Terraform language documentation and you go to functions on the left-hand side, you can see there are a bunch of functions here that you can use. You can use string functions like format, which is kind of one of my favorite ones, and it allows you to format your strings in different ways. Well, we can test that in Terraform console. If we type format and we do my app droplet ID is, and then we do %s for a string, we can do DigitalOcean droplet.app.id, and now that interpolation was processed, and you see here my app droplet ID is 238883790. And that's powerful because now instead of trying this interpolation inside of my code and doing a trial and error, I can just test it here. This is one of my favorite commands because it allows you to test functions and interpolations without having to worry about writing new code. You can run another command like the timestamp to get the current timestamp. And all of these functions here that are listed in documentation, you can feel free to read and see. You can test them in Terraform console, which is really nice. I used it a bunch to test the CIDR host and CIDR mask and CIDR subnet ones when I was working through a problem that I had to create, various numbers of subnets in a cloud provider. Terraform console is probably one of the most underrated commands. I definitely encourage you to just use it and get familiar with it, right? It's pretty fun to use it, and you can really learn a lot about interpolations and how your data is going to look when you use this Terraform console command. And that's Terraform console. Terraform format allows you to format Terraform configuration files so that they appear clean and are very readable. And the format command is actually FMT, but you can call it FUMT, you can call it format. I like to call it format. If you run --help, you'll see it rewrites all Terraform configuration files to a canonical format. TF files, TF-var files, TF.json, all of them are modified. I'm sorry, JSON files are not modified, but TF and TF-var files are. This is cool because this allows you to keep your configuration very clean and very uniform. In fact, if you were looking, some of my videos, you'll see that I have configured my editor to automatically format. So if I change the formatting here and I make the equal signs very uneven, if I do things like that, when I write my file, it bounces right back, right? That's because I configured my editor to run Terraform format on save, on file save. But you don't have to do it through your editor. You can actually run Terraform format directly. So let's just make a copy of the main.tf and call it unformatted. Let's edit this for a second. I'm going to unformat it. You don't see the highlighting because my editor now doesn't think that this is a Terraform file because of the extension. I'm going to just modify this file here. And now I'm just going to copy it over my original file so that I have a clean file to work with now that's unformatted. So now if I run Terraform format --help, there are a lot of options here. One of which I want to show you check and I want to show you diff. So if I run Terraform format -check -diff, it's going to display, it's going to read all of the Terraform files in my current working directory, and it's going to tell me, hey, these are not formatted correctly. Here's what you have, and here's what I would want it to do. And notice how it wants to snap it back and line up the equal signs again. This is another good command that you want to run in CI because as users are making change to your, Terraform configuration files, you might want to run check with diff in order to run on a pull request or something and say like, oh, you've committed changes to these Terraform config files, but it wasn't formatted. And you can give the user a warning so they can fix that before you merge that pull request. If you actually wanted to write this stuff, you can do something like write dash false or remove check. I'm sorry, write dash true, or you can remove check. If you just run Terraform format with no arguments, it'll actually read all of the files in your current directory, all Terraform files, and format them in place. So if I run that, notice how it gave me back main.tf. It'll give you back the output of all files that it formatted for you. Now if I open up main.tf again, notice it's formatted again because I ran through Terraform format. So Terraform format is a great tool to use in CI, or even before you commit changes to your repositories. You can run it locally just to make sure everything is looking nice and clean. Again, another underrated command in my opinion. I think format should be under the main commands, but that's besides the point. Format is really, really useful to keep that code clean and keep it very readable. And that was Terraform format. Terraform force unlock allows you to forcefully unlock a backend's state file so that it can be accessed again. Not really a well-known command or even a highly used command, but if I run terraform force unlock -- help, you'll see what it says. It says manually unlock the state for a defined configuration. This will not modify your infrastructure. It just removes the lock on the state. The behavior of the lock is dependent on your backend. Local state files cannot be unlocked because they don't have locking like that by another process. This is something I can't really demo right this very second because I don't have another backend. But basically, when you're using a remote state backend where you're storing your state file somewhere remotely instead of on your local machine, Terraform has this concept of state file locking. And what that means is if a given Terraform process is interacting with that state file, it will request a lock, right? Similar to how you lock a database to perform a transaction, right? Terraform will request a lock, and it's basically saying, hey, I'm the only process that can read and write this state file right now because I have a lock on it. And this prevents collisions in the same state file because you don't want to ever have two Terraform processes writing to the same state file because that can cause corruption. So when Terraform runs in a remote backend situation, it'll request a lock on the state file, says, hey, I'm the only one that can modify this state file until I unlock it. And then once it's done, it'll unlock. Sometimes bad things can happen and your state file can be locked by Terraform, but then that Terraform process gets forcefully killed somehow, or something happens, maybe a panic or whatever it may be, and the lock isn't removed from the state file. So Terraform force unlock is here so that way you can actually force unlock a state file in those events. And that's really all it's ever used for. Not even gonna lie, I've never run this command before in production because I never had to. But your mileage may vary. Like I always had other ways to unlock the state file rather than this command. So I probably used the API or something else. But either way, this command you might not have to run in your lifetime when using Terraform, but I'm covering it for completeness, and now you know that it's there just in case you need it. And that was Terraform force unlock. Terraform get allows you to fetch the modules for a given Terraform configuration. If I run terraform get -- help, you will see that it downloads and installs modules needed for the configuration. It recursively downloads all modules needed, etc., etc., etc. Module installation also happens as a part of Terraform init. So again, this is another command that you might not run too often. You might not run terraform get that often because Terraform init does the job already. And it says it here. You should rarely need to run this command separately. But again, we're going to cover it for completeness. Now, we haven't really covered modules up to this point, but I'm going to show you this configuration I have. And in here, I have a module directory, or I'm sorry, a module block, and its name is null. It's going to read a module from this source. So / modules null. So in this directory, I have some Terraform module code. And this namespace equals is just a variable that I'm passing to this module. Again, we're not really covering modules here. I just wanted to show you the setup first. If I look at modules null main.tf, you'll see in here, There's a null resource, a namespace variable, nothing much going on here, nothing crazy, right? Nothing like over the top. So in here, this configuration is not actually initialized. Nothing's actually happening here. You'll notice I have nothing here except for the main.tf and the modules directory. If I were to run Terraform get, Terraform is going to actually go out and fetch my modules, download them, and install them into my .terraform directory. Now, if I run ls-la, you'll see I have a .terraform directory. If I were to run tree on that and just to see the directory structure, you'll see that Terraform went out and it creates this module.json file, which holds the modules that I'm using in this configuration. Now, again, I know we haven't really covered modules yet, but really all modules are more of like a package of Terraform files, so to speak. You know, a module of Terraform files that can be run as an individual unit. I kind of like to think them as like almost like functions, right? Because modules take input and they give output sometimes. So you can write Terraform configuration as a module and give it certain inputs. So a common case would be creating a Terraform module to spin up some sort of virtual network in a cloud provider. So you'd call that like, you know, a VPC module for a given cloud provider. It takes inputs, creates a VPC module, and gives you outputs. So I'm sorry, takes inputs, creates the VPC in your cloud provider, and gives you outputs back. But again, not the focus here. Terraform get will just go and fetch those modules, but rarely needed because Terraform init will do the same thing for you. So that's Terraform get. Terraform graph allows you to create graph files so that you can view them and see how your Terraform configuration looks as a graph, right? Like see the dependencies of your resources. Now, if you just run Terraform graph -- help, you'll see that it outputs the visual execution graph. This graph is outputted in dot format. A typical program that could read this is called GraphViz. So you might want to install GraphViz if you don't already have it. I just had to install the GraphViz package for my operating system here. And you can see there's a couple flags here that you can use to actually change the type. But if I just run Terraform graph, so Terraform graph, you'll see that it gives me some sort of directive graph here, right? Some sort of graph file here. And you might be saying to yourself, Matt, what does this even mean to me? Well, it doesn't really mean much to you, right, in this format. But if you run Terraform graph, if you already installed GraphViz and you have it installed in your system, you run Terraform graph and you pipe it to the dot command -t svg, and then you run that and write that to an svg file. You'll notice now you have this nice graph.svg. And if you just open it with whatever your operating system's command has, you can view this graph here and it looks pretty cool actually. So I'm going to open this up and make it a little bit bigger here, like 200%, and just open that up. You'll see this is the graph of my configuration here. And this is the configuration that I've been showing before. You'll notice it's a directed graph. So the arrows point to the nodes that have to be created first. So you kind of read this backwards in a sense. If you look at the bottom, it says there's a provider called DigitalOcean. It's going to create this SSH key called admin, who in turn is going to create this DigitalOcean droplet app, blah, 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 right? So it's not really creating in that way. It's just saying, hey, I have, if you read from the middle, I have a DigitalOcean droplet called app who depends on a data DigitalOcean SSH key, who depends on a provider. So you can start to see the dependencies here, which is actually pretty nice because this is how Terraform actually internally works and determines what resources to create first, what resources to create second, etc. And it draws this graph and it says, hey, this needs to be created before this needs to be created before that, etc. So in this case, you can see all of these DigitalOcean droplets that are at the same level here, they're all next to each other, they're all peers, so to speak. They can be created in parallel because they don't have any dependencies on each other. So all three of these can be created at the same time, but they all rely on the data DigitalOcean SSH key admin. So this data source needs to be refreshed before any of these droplets can be created. This graph's pretty cool. If you have a large Terraform configuration, you should generate one of these graphs and see it for yourself. Again, this is one of the things that I don't normally use too often in my my daily use of Terraform, but it's there for those cases where you're working on a new code base and you want to see like how it looks, you can generate the graph and figure it out from there. And that is Terraform Graph. Terraform import allows you to import a manually managed resource, right? Something that you've created outside of Terraform. It allows you to import that resource into Terraform so that Terraform will begin to manage it now. If we look at Terraform import and we do -- help, you'll see a bunch of options. Again, read through them in your leisure. It'll import existing infrastructure into your Terraform state. How? Well, you'll give it an address and you'll give it an ID. So the address that you give it is the fully qualified name of the resource that you want to import. The ID is a resource specific ID to identify that resource being imported from your provider. Great. What does that all mean? Well, it says, please reference the documentation for the resource type you're importing to determine the ID syntax. It typically matches directly to the ID that the provider uses. Okay, so a lot of words here. Well, what's the use case here? So if you look at my configuration, I have these 3 DigitalOcean droplets, right? App, DB, and Bastion. And Terraform knows about it because if I look at the state file, you'll see that it has it in here, right? DB droplet, Bastion droplet, app droplet, and then the data SSH key, and that's all it has. So the use case here is, what if an admin went into your cloud provider, right, and created something by hand? So let's try to create a droplet here. And I'll do this quickly. CentOS, basic, AMD, $6 a month, New York 3, my admin SSH key, 1 droplet called default backup droplet, and I'll give it the tags of default backup to follow the methodology we're using here. And let me create that. So let's say some sort of sysadmin or sysengineer went in here and manually created this default backup droplet, and they didn't know you're using Terraform, and they just manually went in there and created it. That's fine. You don't have to destroy this to get it managed by Terraform. You need to import it, because now this resource exists in reality. But if you go back to Terraform and you run, Terraform plan and give it back its default value, you'll see no changes, infrastructure's up to date. It doesn't know about this backup resource. You have to import it into your configuration for it to be useful. So let's do Terraform provider DigitalOcean. Let's look up the actual documentation. We'll go to the resource that we want to import, which is going to be a droplet. And you'll see on the right-hand side, there's this little import tab here. And it says, hey, you can import a droplet using its ID in this syntax. Terraform, import, the resource identifier, right? So DigitalOcean dot the name, and then the ID of the actual droplet from DigitalOcean. Okay, so we need a few things here. We need this address, and we need this ID. Let's get the address first. So before you can import any resource, you have to have a resource block inside your configuration to receive that import, right? Here, I don't have one yet. So I'm going to copy an existing one and I'm going to modify it. And instead of it being called DigitalOcean Droplet Bastion, it's going to be called Backup. So instead of Bastion, Backup, and instead of Bastion, Backup. So now I have a resource block to receive the import, right? So I have that part. So I'm going to do Terraform import DigitalOcean _ droplet dot backup. But I still need the ID of the droplet to import. So where am I going to get that ID from? Well, I can go into DigitalOcean. I can click on the droplet. You'll notice in the URL, the ID is there. Now, this is a pretty simple way to get it. Some cloud providers give you the ID in the actual web UI here. It'll have a place that it shows you the ID. You could also use the API to get the ID. But in here, I see it in the URL. So I'm going to grab it straight from the URL. And now I'll replace ID with the ID that I want to import. And give me my namespace because it's a required variable, even though it's not needed in this context. And Terraform is now reaching out to DigitalOcean. It's reading the droplet with this ID. It's importing it into my state file, and it's refreshing my state to write it. And it says import successful. These resources were imported. And now if I look at my terraform.tf state, you'll see that there is a new DigitalOcean droplet called backup. And Terraform reached out and it found out everything it could about that droplet, including its IP address, the image it's using. Remember, none of this was defined in Terraform, right? Like Terraform didn't define this and know what it was. It reached out to DigitalOcean, read the information, and imported it and matched it back up to my backup droplet that we have there. And now, if we run Terraform plan, give it the name for namespace, it'll say, hey, this backup droplet is there. And you'll notice all it wants to do is it wants to update the SSH key because that's something it didn't want to do before, but it's imported, right? It's not trying to destroy it. It's not trying to create the droplet. It just wants to now add the SSH key to the droplet because maybe I missed it when maybe I didn't check that SSH key when I first did it, but no worries. So I can actually just run Terraform apply on that and then let it update the SSH key. Boom, run Terraform plan again, default. And now that backup droplet is managed via Terraform. I've rolled it into my state file and it's now managed by Terraform. So that system admin that manually created it before, I can go back to that person and say, hey, this is now managed by Terraform. Please don't touch it anymore. All changes go through Terraform, etc. Now I've rolled in existing infrastructure to be managed by Terraform. This is useful when you have manually created infrastructure and you want to start managing it with Terraform. And that was Terraform import. The Terraform login command allows you to reach out to a Terraform Cloud or Terraform Enterprise host and grab some credentials and write them locally to a file. If we run Terraform login -- help, you'll see that it retrieves an authentication token for the given host name. It'll save it in credentials file. If no hostname is provided, the default hostname is app.terraform.io, which is Terraform Cloud. If you're running Terraform Enterprise, you can give it your own hostname to your Terraform Enterprise instance, and it'll run it there. You'll notice it's going to try to write the configuration to this file. Well, let's see what happens. Terraform login, we can run that. It says, hey, Terraform's going to request an API token for app.terraform.io using your web browser. If the login is successful, Terraform will store the token in plain text in this file. Do you want to proceed? Yes, I do. I'm going to launch my browser. It's going to prompt me to log in. I'll sign in, verify with two-factor auth, and it says, hey, it'll prompt you, please create an API token. I'm going to call it Terraform login, create the API token. You'll see that it says it's right here. I'll copy it and I'll hit done. Go back to my terminal. It's going to ask me the value for the token. I'll paste that in here, hit enter, and it successfully saved it to that file. Now, if I want to just see what it is, I can cat out that file, and you'll see here's my Terraform Cloud API token. No problem. This allows me to use my Terraform Cloud as a remote backend for certain Terraform configurations if I wanted to go that route. And since the credentials are stored in my local machine, it just saves the credentials for me so I don't have to hard code them in my configuration later on. I'm not going to go through that step right now. I just want to show you that login is there to automate that process of creating your token for Terraform Cloud. And that was Terraform login. Terraform logout will actually remove your credentials from your local file and log you out of your instance. Let's see. If you run Terraform logout -- help, it'll say it'll remove your locally stored credentials for your specified Terraform Cloud or Terraform Enterprise host name. If no hostname is provided, the default hostname is app.terraform.io. Great. So let's run it. Terraform logout. And it says, hey, I'm going to remove the credentials for app.terraform.io from the following file. So now, if I actually cat out that file, you'll see that there's no credentials there. But one thing you want to do is you'll want to log back into Terraform Cloud, and the API token is still there. So you're going to want to delete the API token if you're not using it anymore. Just removing it from the local file using Terraform logout doesn't actually delete the API token on the Terraform Cloud or Terraform Enterprise side. So you'll want to log back in and delete that API token. And at that point, you're actually safe because the API tokens delete it from your local file and from Terraform Cloud or Terraform Enterprise. And that was Terraform Logout. Terraform output allows you to view the outputs for a given configuration. If you run Terraform output -- help, you'll see that it reads an output variable from a Terraform state file and prints the value. With no arguments, the output will display all outputs for the root module. If name is not specified, all outputs are printed. So let's run Terraform output. And you'll see it gives me the outputs of that I specified in my actual configuration file. Let's update the output to do something else. Let's actually create a new output. Let's do output testing, and the value here is just going to be DigitalOcean droplet.backup.id. So nothing crazy here. Actually, let's take the testing away and call it backup droplet ID. Okay, so we've defined a new output. If we run Terraform apply against that new output, you'll see that Terraform is going to update its outputs. It's going to add that new output, so we'll update it, and they're there. If we run Terraform output again, let me just clear Terraform output, it'll show us all of those newly created outputs. If we just want one of them, we can just get the info output. We can just get the backup droplet ID output, and it allows us to access these outputs for use in other things. This is useful if you wanted to pull some outputs from a state file in order to use it in some sort of automation or whatever you wanted to use it for, or just kind of see the outputs in a clean way. Because some Terraform configurations can output tens or hundreds of outputs, and filtering through them is a little difficult. So this allows you to kind of view them in a more clean and systematic way. And that's Terraform output. Terraform providers command allows you to print out the Terraform providers that are being used in your configuration. If you run Terraform providers -- help, you'll see that it prints out a tree of modules in the configuration with the requirements. Now, that'll print an overview of all your providers across your reference modules so you can understand why a particular provider is needed if you have some sort of version constraint that you're using. The providers command also has different subcommands like lock, mirror, and schema. Lock will write your dependency locks, mirror will save local copies, and schema will show the schemas for all providers using in the configuration. I don't recommend running the schema command because you'll have to give it the JSON argument and it's going to give you a large output. But let's just cover the Terraform providers command in general. You'll see here, these are the providers that are required by my configuration. The DigitalOcean provider version 2.6.0. And here is the providers that are required by my state file. So nothing magical going on here, but I just wanted to show you that this Terraform providers command can kind of give you a look at what providers are we using, where they're being used from, and it's a good way to, if you're looking to upgrade a provider version, it's a good way to see what parts of your code actually want a given provider before you update the provider version. And that's Terraform providers. Terraform refresh will allow you to reach out to the provider, read any updated metadata from anything that's managed in state, and write those changes to the state file. If we actually run Terraform refresh -- help, you'll see that it updates the state file with any metadata that matches the physical resources that they've been tracking. So when is this really useful? Well, let's say you had a sysadmin, right? Go in and go into your infrastructure and update something that wasn't managed by Terraform. Well, what do I mean? Well, if I look back at my configuration here and I cat main.tf, you'll see I have a data source here, right? And this is a DigitalOcean SSH key called admin, and it's looking for any SSH key within DigitalOcean that's called admin-SSH key. And it'll reach out, it'll grab the details about that and import them into your state file. That way you can use those interpolations in your configuration, like down here, right? The ID attribute on the admin SSH key comes from this data source. Notice I don't know the ID here. I'm telling Terraform, go out to DigitalOcean, find an SSH key called admin SSH key, get its ID so I can use it in my configuration. Well, if we look at the state file for just a second, actually, and if we go down to the DigitalOcean SSH key here, you'll notice this is the data source. You'll notice here's the ID 299.03171. And here's the actual public key content here, right? It ends with WDNVJ. Well, if an admin went in here and edited this SSH key and changed the key to something completely different and saved it, well, now my state file is technically out of date, right? Because this is no longer the SSH key that's in there. My new SSH key, it ends with 2ZKE, right? So that's a different SSH key. So if I were to run Terraform refresh, give it that required variable, Terraform is going to go out and refresh the state and write any changes to the state file. Now, if I look at my Terraform TF state, notice it's went out and it's updated the SSH key ID. And now it knows that this SSH key ID has this new public key and whatnot. So it went out and refreshed what it knew about anything that's in its state file. Oftentimes, there shouldn't be a drift like this, but it could occur in this scenario, right? Where we don't actually manage the SSH key in Terraform. We just go read it. Some other admin somewhere has created this for us. We're just going to read the data from it. So this is a situation where it's useful. And now if I ran Terraform plan, gave it the name, you'll see that there's no changes because the SSH key's ID didn't change, just the key inside did. So there's no changes here. So that's where refresh can be useful. Again, it's one of those commands that you're probably never going to run, and you probably shouldn't run, because Terraform plan is kind of going to take care of that for you. And then the apply is definitely going to take care of that. Notice here when I ran the plan, it says refreshing state. Terraform plan and Terraform apply, they do a refresh for you. So no really need to run this command manually. But again, I wanted to show it for completeness. And that's Terraform refresh. Terraform show will show you the configuration that's currently being managed by Terraform. And it'll show it to you in a way that you could actually see the state file or plan in a more human readable form. So if you look at -- help, it'll read and output a Terraform state file or plan file in a human readable form. If no path is specified, the current state will be shown. So if I just run Terraform show, it'll print out my entire state file in a human readable format. Actually, this is in HCL format. So technically, this is valid Terraform code right here. And you'll see now this is easier for me to read, right? I don't have to read that JSON file anymore. This is a lot easier. I can read my data source, I can read my resource, and this is everything Terraform knows about the state file. I still actually have that plan file from earlier, and you can run Terraform show on a plan file, and it'll tell you what it wanted to do in that plan file. So if you ran Terraform plan and you output it to a plan file earlier, and you still have a plan file around, you can see that. You can actually see that in a human readable way just by passing it to Terraform show. What I do like about Terraform show though is this. So I could run Terraform show, right? Like I just did, but it has like arguments like JSON. So I can write out my actual state file as readable JSON, and I can just send that off to a machine to process my Terraform state file in a better way. So that's another pretty cool thing. This is useful if you're going to write scripts or things and want to parse the actual infrastructure that Terraform's managed. But Terraform show is nice when you want to kind of get that overview of like what the values really are, because this allows you, mind you, if I look at my configuration, right, let's take the DB droplet, for example. If I go to that in my code, I don't really see a lot of information here, right? I don't know what var.namespace is. I don't know what data DigitalOcean SSH key is. I don't know what these values are. But similarly in the state file, if I go to the state file and I go to the DB resource, this is a bit hard to read. It's not clean, it's JSON, it's a little bit annoying to read this. So when I do Terraform show and I see my DB droplet, it's a nice clean format that I can see, oh, this is droplet ID this. It has this IPv4 address. It is not locked. It has this SSH key, etc., etc. So another way to just view that configuration in a human readable form. And that's Terraform show. Terraform state allows you to interact with the state file to perform certain actions. If you run terraform state -- help, you'll see that this command has different subcommands that you can run, and there's not really much you can do with just terraform state by itself. You kind of need to give it a subcommand. And the subcommands are list, move, pull, push, replace provider, rm, and show. Let's do list first. Terraform state list will give you the full resource identifiers for all resources in the Terraform state file. So you can see here I have 5 resources, 1 data source and 4 resources. This is the full identifier for my SSH key data source. This is the full identifier for my app droplet, my backup droplet, my bastion droplet, my DB droplet. And I can use those to see what's in my state file. Now, what's cool about this is I can move things around. If I didn't want to call, if I ran terraform state move and do -- help, this would allow you to move an item in the state to a different address. So if you wanted to like rename resources, you can do this with the actual state file and moving things around. I'm not going to do it here, but I just wanted to show you that it exists. A cool thing is terraform state pull. If I do terraform state pull, it'll print the state file to standard out. So I can like back up my state file with this, right? So I can do like backup.tf state. And now I have a actual backup of my Terraform state file, irrespective of the one that Terraform's doing. I'm just going to remove that because I don't need it. Terraform state push, subsequently, I'm not actually going to run this. I'm just going to run -- help. Terraform state push allows you to write an entire state file to the remote state. This is usually used to take a state file and push it to a remote state management solution. That way you can update the state file if you needed to. Maybe you made some manual changes locally and you want to push those changes. That's fine. This works with local state, but it's kind of less useful because you can just work with local state directly. So no need to just run push. Then you have terraform state -- help. Then you have replace provider. I'm not going to cover this one, but in this example, let me just run terraform providers again. We have this DigitalOcean provider, right? And it's coming from this registry, registry.terraform.io. If you like forked the DigitalOcean provider and installed it under your organization's domain somewhere and you have it listed there, well, you can start using that provider instead, but you'd have to go back into your state file and replace all occurrences of that provider with the new provider. And that's what replace provider is there for. Then you have state rm, which I'm going to cover in a second. So terraform state rm and then -- help. This allows you to remove an item from the Terraform state, which will tell Terraform to forget about that resource. It won't actually destroy it with your infrastructure provider. It'll just tell Terraform, hey, you're not going to manage this resource anymore. So don't worry about it. Just remove it from your state file. And then there's Terraform state show. When you run Terraform state show, you have to give it the identifier of a resource to show. So I'll run DigitalOcean droplet.backup, and that'll show me. Remember when we did Terraform show earlier? That showed everything. Well, Terraform state show allows you to limit your shows just to one item in the state file. Let's go back to RM for a second. Let's say that this backup droplet that was created manually before that we imported, let's say it actually doesn't need to exist anymore. We don't really need it anymore. It's not serving its purpose. We want to get rid of it. Well, the very first thing we might want to do is we want to tell Terraform, hey, we don't want you to manage this anymore. We don't care about, this backup droplet anymore. So just stop managing it. Well, we can do something like this. Terraform state rm DigitalOcean _droplet.backup. And now it's removed from the state. So if I do Terraform state show against that resource again, it's not there anymore. It's not in my state file. Terraform has forgotten about that resource, but it still exists in the real infrastructure. Notice it's still right here. If I refresh the page, it's still here. It's still running in my cloud infrastructure provider. At this point, I'm free to just destroy this resource and get rid of it. So I'm going to go ahead and do that. I'm going to destroy it, confirm. Now it's gone. Terraform forgot about it. I really destroyed it in the infrastructure. And if I run Terraform plan, you'll notice droplet backup wants to be created again. Why? Well, I left it in my config file, right? So Terraform is not managing it. It's not existing in DigitalOcean, but I still have it here in my config file, and Terraform's going to want to create it again. So even though I told Terraform not to manage it anymore, that's fine. It's still listed in the configuration file, and Terraform's like, hey, you want me to create this backup, this droplet, I'm going to create it for you. So if I really wanted to get rid of this, I can just remove this resource from the config file and be done with it. And then now, if I run Terraform plan, I can actually remove this output. Sorry, I forgot about this output. I run Terraform plan now. And it's going to say, hey, I don't actually have that to manage. We're just going to change this output and remove it. And that's fine. I can apply it. And now that backup droplet's gone from the state, from the config, and from reality. So now that is completely unmanaged. And that's one way to like stop managing a resource. But we'll see alternative ways to actually destroy a resource without unmanaging it. This Terraform state rm command is good for when you want to decommission a resource entirely, right? We're not going to be using it anymore at all. So we remove it from the state, remove it from the config, and remove it from reality. And that means that resource is decommissioned, not going to touch it again. And that was the Terraform state command. The Terraform taint command allows you to mark a resource as unhealthy, so to speak. So what does that really mean? Well, if you run Terraform taint --help, the term tainted in terms of Terraform says that, hey, it signals to Terraform that this resource, when it's marked tainted, is not functional. So the next time you want to go apply, a tainted resource will be destroyed and recreated because it's marked as tainted. And what that says is it's a good way to recycle an instance from your configuration. For example, if a given resource came up, but it came up in an errant state, you might want to use taint so you can recreate it. You know, maybe some intermittent error happened during the initial creation. You just taint the resource, recreate it, and it'll be good to go. Let's see what taint actually does. Well, if we run Terraform taint, it says, hey, you need to give me an actual address to taint. Let's say our bastion droplet is in an errant state and we need to redeploy it, right? Destroy it and recreate it. Well, I can pass it the actual identifier to the taint command. So DigitalOcean droplet bastion. And now it says, hey, resource DigitalOcean droplet bastion has been marked as tainted. Run Terraform show. And you see it. Notice it's marked as tainted now. And I could even see this in the state file directly. If I look for tainted, you'll notice that my bastion droplet has a status of tainted. So this is marked as tainted. Now, what does that mean? Well, if I did a Terraform plan, gave it the namespace variable, it'll say, hey, your bastion droplet is marked as tainted, so it must be replaced. So when you mark something as tainted, you are telling Terraform, hey, if this resource exists, destroy it and recreate it. It is tainted, it's not in a good state, recreate it. And this is a good way to destroy and recreate resources. If you don't actually want to do this, you don't have to run this apply, and that's fine. In this case, I'm actually going to run it and then give it the default and hit YES. And now it's destroying the actual bastion droplet because it's tainted. Once the destroy is actually finished, it's going to recreate a new one in its place. And you'll notice here, a good way to see that is that minus plus in the plan, right? But read the plans. That's your best bet. It'll tell you exactly what's going to happen here. And if we look at the actual DigitalOcean panel, we can see if we refresh that the bastion droplet was destroyed and now it's getting recreated. You can see it's creating. And once this is actually done creating, I want to show you what the actual state file looks like. So it should just be another couple seconds. Now let's run Terraform show again. You'll notice the bastion resource is no longer marked tainted anymore. So if I were to run another plan, it's not going to want to do anything. It's going to say no changes. So when you mark something as tainted, the next time the apply operation happens, it'll destroy it, recreate it, and then mark it as untainted So that way you're free to go. So tainted is good for those one-offs like, hey, this just needs to be recycled. It didn't come up right. And that's Terraform taint. Terraform untaint takes a tainted resource and it marks it as untainted, right? It marks it as not tainted. So if we run Terraform untaint -- help, you'll see that this command removes any resource that was tainted and marks it as untainted. So for example, before we tainted the Bastion droplet and then we did Terraform plan and we saw that the plan wanted to actually destroy and recreate the Bastion droplet because it's marked tainted. If we actually didn't mean to taint this, we can just untaint it. So I'll run untaint, and now it's been untainted. If you run our plan, you'll notice there's no changes again. We've just unmarked it. We undid the taint. This is useful for when you accidentally tainted a resource that you didn't mean to, and you just want to mark it untainted. And that's Terraform untaint. Terraform version tells you the version of Terraform that you're running. If you run Terraform version -- help, you'll see that it just displays the version of Terraform, and the only option it has is to output the version as a JSON object. But what I really like about Terraform version that's kind of makes it a bit of an underrated command too, is when you run Terraform version, not only do you get the version of Terraform you're using, it also will print out the providers that you're using if the workspace is already, if your configuration is already initialized, and if you're running an out-of-date Terraform version and you have internet connectivity, you will actually be told that you're running an out-of-date version. It'll say, hey, the latest version is this. You can update it by downloading it. So this is why version is kind of an underrated command in my opinion. And if I'm ever working with somebody and I ask them like, if they're having trouble running Terraform, I always ask them for Terraform version because it gives a bunch of information just in one command. So that's Terraform version. The Terraform workspace command allows you to list, show, create, remove different Terraform workspaces. If you run Terraform workspace -- help, you'll see that this also takes a bunch of subcommands. You can delete a workspace, list a workspace, create a new one, select one, and show one. Terraform workspaces are an interesting concept in itself, and often they're a misunderstood concept because workspaces from Terraform CLI's perspective are related but still different than workspaces from a Terraform Cloud or Terraform Enterprise perspective. So this is where a lot of users get kind of a bit thrown off guard here. But if you're running Terraform CLI from your workstation or in CI, you're already using workspaces. If I do Terraform workspace show, you'll see that I am actually using a workspace right now. And if I run Terraform workspace list, it lists all of them with an asterisk next to the one that I'm currently using. And you'll notice here, I only have one workspace. It's called default, and that's it. By default, any time you're using Terraform CLI from your workstation or CI, you're using the default workspace, unless you explicitly create a new one and switch to it. So let's actually create a new workspace. Now, Terraform CLI's concept of workspaces is really just kind of namespacing for state files. For example, if I run Terraform plan and I run the default namespace variable, it says, hey, you already have everything up to date. There's no changes here. But if I were to do something like this, Terraform plan, and give it a namespace of, I don't know, sudo Mateo, notice what's going to happen here. It's going to want to make changes, right? It's going to want to change the name of my droplet from default app to sudo Mateo app, default bastion, sudo Mateo bastion, default db, sudo Mateo db. I don't necessarily want this, right? Because I still want to keep my default, but I might want to create a new set of droplets called, in the namespace sudo Mateo. And this is where I said earlier before that naming collisions on resources becomes important in situations like this. Well, let's see how we can handle this with a workspace. If we do Terraform workspace new, and it wants to give you a name, so give it a name called sudo Mateo, and then I do Terraform workspace list, you'll notice that I now have a new workspace, and I'm already switched out to it because my star showed me that. If I do Terraform workspace select default, I go back to my default workspace, and I can see that with the list command. So now if I run Terraform plan, give it default, it says no changes here. I'm still in my default workspace. If you look now though, if I run ls-la, this new directory came up, terraform.tfstate.d. Let's look at what that is. Notice in here, there is a directory called sudo Mateo. This directory is the same name as my workspace sudo Mateo that I just created. And that's kind of what I mean about workspaces are nothing more than namespacing, but for Terraform state files. And you'll see what I mean. Let's Terraform plan, right? Give a default. We know that this is going to give us no changes because we're using the default workspace, and the default workspace uses this state file right here, which already has data in it. Let's switch my workspace to sudo Mateo. And now I actually want to do Terraform plan on this. And instead of default, I'll give it a different value like sudo Mateo, like whatever. You'll notice here, it wants to add resources. Why? Well, it wants to add because we're using a different workspace, and this different workspace doesn't yet have a state file. So since it doesn't have a state file, Terraform's like, hey, you want to create all these resources, don't you? Well, yeah, we kind of do. So let's run Terraform apply, give it the sudo Mateo name for my namespace, hit yes, and watch it create. Now, the namespace variable that I have here is not the name of the workspace. This is just a namespace variable to prevent naming collisions of resources in the DigitalOcean cloud provider. It just ensures that I don't name my resources the same way. That's all it's for. It has nothing to do with workspaces in this regard. You'll notice now it's creating these resources, and if I go into DigitalOcean and refresh, you'll see 6 droplets, 3 under the default namespace and 3 under the sudo Mateo namespace. Now the cool thing about this is these bottom 3 that have the default namespace, they're being managed in my default Terraform workspace, which is using one state file, right? Terraform.tfstate. But these 3 droplets up top, these sudo Mateo ones, they are using the sudo Mateo workspace, which means they're using a different state file in Terraform state.d sudo Mateo. Now that the apply has completed, if we run ls-l again on the Terraform tfstate.d sudo Mateo, you'll see that there's a terraform.tfstate in there. Let me just show you what the tree looks like of this right now. In my current directory, I have this Terraform tfstate. This is referring to the state file for my default workspace. And then in this nested directory structure, I have this sudo Mateo directory with its own terraform.tfstate. So when I'm using the default workspace, I'm using this tfstate. When I'm using the sudo Mateo workspace, I'm using this tfstate. This is what I mean by that namespacing for Terraform state files when you're using workspaces. Now, I'm using the same configuration, but with 2 different state files. So it allows me to have 2 different sets of infrastructure managed completely separate. If I wanted to run Terraform destroy, and I give it the value sudo Mateo, it's just going to want to destroy all infrastructure that's under the sudo Mateo workspace because it's reading the sudo Mateo's workspace's state file. So if I hit Control C for that and not actually run it, if I switch back now to Terraform workspace, select default, now I'm back on the default workspace. If I run Terraform destroy again, pass it default, notice it wants to destroy the default droplets because now we're in the default workspace, which is using the default workspace's Terraform state file. So I know it's a bit confusing to follow at first. I'm going to switch back to the sudo Mateo workspace. I'm going to run destroy. I'm going to give it sudo Mateo. I'm going to hit yes to let that go. I know it's a bit confusing at first, but think of workspaces as namespaces for your Terraform state files. And this is where naming collisions come into play because I've seen people, they write Terraform configurations and they have some static values in there, right? And they create infrastructure and they're like, oh, I want to do workspaces. And they create a new workspace and they rerun Terraform and they get an error because they have a naming collision. They either create 2 different VMs with the same ID, they create 2 different databases with the same ID. I've seen it where people create 2 different S3 buckets with the same ID. S3 buckets in AWS have a unique identifier, so you can only create one bucket with that name per, I believe, region or globally. I don't remember. So I see people do that. They're like, oh, but I'm using workspaces. Doesn't that namespace it? It namespaces the state file, not the resources. You, as the engineer, are responsible for namespacing your own resources. Terraform workspace create or select, it'll namespace your state file for you, but it will not namespace your resources. That's why I have the namespace variable here in my configuration. This namespace variable is me namespacing my resources, not my state file. Terraform workspace commands allow me to namespace my state file, not my resources. So they kind of work hand in hand to make sure that irrespective of the workspace I'm using or irrespective of the configuration, I have a way to get unique resources in there. And now that all the sudo Mateo droplets and stuff are destroyed, I can actually switch back to default and then do the last workspace command that we didn't cover, which is Terraform workspace delete sudo Mateo. And if I do Terraform workspace list, you'll see that that workspace is gone. If I do ls-l, you'll see that the state file still exists there. If I do tree, I'm sorry, it doesn't exist there. They actually remove it. My bad. That's what I meant to say. Once you delete a workspace, the state file actually gets deleted with it. So you might want to make sure you destroy your actual resources before you destroy the workspace. And now I'm kind of back to where I was before. I just have one workspace, which is the default, and is using this TF state file. And I know that was a lot to handle, but that's Terraform workspaces from a CLI perspective. And again, I just wanted to note that they differ. They're related, but they're different than workspaces from a Terraform Cloud or Terraform Enterprise perspective. And that was Terraform workspace. And that's it. That's every single command that's included in Terraform at the time of this recording. I hope you learned something for this, and I hope you see how Terraform can be used in a variety of different ways, and now you have more confidence to use Terraform in the field. If you enjoyed this video, please like and subscribe to the channel. And if you want to see more content like this, or if you want to see different content, please contact me and see what, tell me what you'd like to see. I can make videos on various content. I usually stick to Terraform right now, but if you have something you want to see or talk about, please leave a comment and I'll be sure to get back to you. Thank you again for watching this video, and I will see you in the next one. Take care.